So today we are writing transformations using function notation and transforming piecewise. A piecewise is a function that has different functions as pieces of the whole. So if you look, this is a function because remember in no two places does it have two input values or does it pass it passes the vertical line test. You can look, this first part is quadratic and the second part is linear. So you know so you can see the two pieces. It could have also been two quadratic. It's just easier to show one or two different types of functions. So it could have been quadratic and then another quadratic, but it's just quadratic and linear. It could be two quadratics. A piecewise just means there's multiple pieces in that function. So if you look, let me move this out of the way. If you look at this right here, this is another piecewise function. Notice this function notation. We're going to talk about that in just a second. But the a, notice, is still out in front of the x. There's just an f with it. The h is still inside the parentheses and the k is outside. All of those values are still going to do the same thing. The a stretches if it's larger than 1 or compresses if it's smaller than 1. The k moves it up or down. The h moves it left or right. I'm going to talk about why it looks like this and why it's not moving the opposite direction in just a second, but let's write out our transformations using function notation. So writing transformations using function notation. Okay, what that means, and the reason we use function notation is to say how to transform an original function. So on that one that you just looked at, it was moving the original. That's why we put the F. So we still have the A is out front. The only difference is it's F of X minus H and then plus K. Notice there's no squared because there is no, it's not talking about a specific function. So it's not talking about a quadratic. It's talking about whatever the original function was, you just need to transform that original function. So the A still, stretches, compresses, and reflects over x-axis. The only difference is it is just to the original. It stretches, compresses, reflects over the x-axis, the original function. So your original function, like on that one that we just looked at over on the Agile Mind screen, is that you can it can have a different a value. It doesn't have to be an a starting off. It could be a 4 and then you make it 2. Since it got smaller, like so from a 4 to a 2, it got wider. Okay. The h value still shifts or translates horizontally. And it's still the opposite, so a negative moves right and a positive moves left. Again, the only difference is that it's to the original function instead of a parent function. It's talking about move the original left or right however much. It could have started at a negative 1 and then move to a positive 4. So if it was at a -1 and moved positive 4, which direction would that move? So from a -1, remember -1's right, a positive 4 would be 1, 2, 3, 4. So, oops, I did that backwards, sorry. So it would still move, it would just move that direction. So from -1 to 4, it went, you can subtract 4 minus 1 minus -1 means it moved 5 units. So it moved 5 units to the left. Okay, and then the K value, I use pink, the K value shifts vertically, again, the original function. Okay, so if we look back at this animation over here, so if I look, this is that original that we just looked at. So this is the original function. So the f of x, so this f of x right here, just means take the original function, either stretch it or compress it, and move it left or right, and then move it up or down. So if I want to make the new function, so see the dashed one? The dashed one is our new function. So we definitely need to move it up and down probably, and then stretch or compress it. So the way I always do this is I always look for a key point. So you could look at this point right here, and notice it moved left and then down. So left and then down. Now if you look at that, it's definitely wider. So I'm definitely going to have to make this wider. Oops, that looks pretty good. And then, oh, I need to move it back up. So there is the equation for that function. So I'm going to write that down. So 0.5 is the a value, f of x. Now it says minus -4 minus 10. So the 0.5 means it was wider. This minus and negative, remember minus and negative is actually the same thing as addition. So minus and negative is the same thing as addition. So then, and notice it moved left, and then the -10 moved it down. So positive, positive, so that's why it moved left 4. It moved the original function left 4. Okay, so that is why we use function notation, because if you look, the original function, I'm going to reset this, the original function, it wasn't at the origin, it was actually over 1, but we had to move it 4 units more to the left. So that's why it looks like that. The -10, that came from moving it down 10. Oops, move it down 10, and then stretch it, or compress it, I'm sorry. This 0.5 compressed it. So that is the difference between function notation and piecewise. Remember, make sure to ask. Just because we're recording a video of me teaching instead of me teaching the whole class, you're still supposed to be asking questions. I know I messed up a little bit on that, so if you're confused on that, make sure you ask me and I will clarify for you. There is an assignment on Schoology. You are going to have to be writing equations using function notation. Actually, you're matching because I didn't want you guys having to type it out. So you're going to be matching the equation and the graphs and all of that. So make sure to ask if you have any questions.